Okay, and as we continue on with our lesson here with this example, what we want to do is we want to match each parent function card with the characteristic of its graph, and we can only use each card once. So here we've got the graph of y equals x. Here's the graph of y equals 2 to the x, an exponential curve. Here is y equals this absolute value of x, and there is y equals sine x. And so the range here for one of the characteristics, y is an element of all real numbers such that y is greater than or equal to 0. Domain is x is an element of all real numbers, infinite number of zeros, and as x approaches negative infinity, y approaches 0. So you can take a look at your chart to sort of narrow down these choices, or you can just take a look at these and see where these characteristics will fit on these graphs. So go ahead and do that, please. So we see that here for this first characteristic, range y is an element of all real numbers such as y is greater than or equal to 0. Well, that doesn't fit the line y equals x. It almost fits the exponential function, but without the greater or the equal to sign, so that still doesn't work. Here we see that y does equal 0 for the absolute value function, and for the sine function, the range is below 0, so it goes down to negative 1. So this range would approach, or would be matched with the absolute value function. Okay, so we've already used this one, and we've already used that. Now, the domain is x is an element of all real numbers. Well, take a look at the line y equals x. This characteristic does match that curve, but it also matches this curve with the exponential function. Domain is an element of all real numbers. This one's already been used, so we can just bypass that one. And the domain is x is an element of all real numbers, also works for y equals sine x. So let's just leave that one for now because it's hard to narrow down on those last three until we get characteristics of other functions here that we see. So here there's one that's infinite number of zeros. Well, we can pretty easily check here to see that the infinite number of zeros would be the sine function because it has zeros every 90 degrees and it goes on forever in both directions. So that would be this case here. So we've used those two. And we still can't narrow down the domain x is an element of all real numbers between these two. So let's take a look at this last characteristic where it says as x approaches negative infinity, y approaches 0. So as x approaches negative infinity for line y equals x, y also approaches negative infinity, whereas in this case with the exponential function as x approaches negative infinity, y does approach 0. Okay, so that is the correct graph for that case. And then the last one that we see here is the line y equals x. Okay. Now there's another couple things here that you've seen a little bit in the previous examples. So now I'd like you to work on these on your own, and we'll check with those tomorrow and just see that you're doing okay with these. State which of the parent functions you've seen in this lesson that have the following characteristics. So the range is y is an element of all real numbers such that y is greater than or equal to 0. So state all the parent functions that have that characteristic, and also for an interval of increase from 0 to infinity, state all the functions that have that characteristic, please. You can use your chart to help narrow down that, and then you can compare these characteristics with the actual graph of the function. So do that on your own, please. And then for the symmetry of a function, we've already done this a couple times, so that if f of negative x equals the original function, then it's an even function. If negative times f of negative x equals the original function, then we know it's an odd function. Okay, so I've shown a couple of examples of those. Can you please work on these at home? And the first few questions, the apply your knowledge section of the homework here, questions 1 to 8, 10, 12, and 14. So chances are, I don't have the textbook with me, it would be questions 1 to 3 or 1 to 4. Do the applying your knowledge at home, and then do the rest of these questions in class tomorrow. Okay, have a good evening. See you in class.